so we have the Algebra 2 Unit 2 review. So this is a review that's going to be very similar to your test. For each learning target, on the review, there are only 2 problems. On the actual test itself, there will be 3 problems. So the actual test will have 4 learning targets, and each will have 3 problems. So there'll be 12 total problems on this test. So let's get started. So for the first 2A, we need to identify the intervals that are increasing or decreasing. So first I want to go from left to right and just figure out what's decreasing and increasing. So decreasing interval, first part of the graph is decreasing, and this decreases from, and it's coming to x values, always talking x values when decreasing and increasing. You're talking from negative infinity, and it stops decreasing at negative 1. Next portion of the graph increases. That's a short increase. This increases. So it's increasing from negative 1 all the way up to the x value of 0. I don't care about the y value, just x value. And the graph turns again, and for a short time it decreases. It's going to decrease from 0 to 1, and it turns back around and starts increasing again. And as it's increasing, the x values are increasing also to infinity. So it increases from 1 to infinity. On number 2, starts increasing, increases from negative infinity. On the x values, the x values are coming from, like this is at negative 3, this is at negative 2 about, up here is at negative 1. So it's increasing from negative infinity. It stops increasing at the x value of 0. The next portion decreases. It decreases from 0 all the way to the x value of 2. Always x values. Don't get the y's involved in this. That'll just confuse things and start getting things wrong. So only x values. So now the x value starts again at 2. And it'll increase to the right as it's increasing. It'll go to the right forever and ever to infinity, positive infinity. 2b, so you need to do domain, range, zeros, and intercepts. So domain. The domain of this function, how far left will that go, and how far right will it go? And it's continuous throughout the whole graph. So this will continue to go to left. This will continue to go right forever and ever. So that's negative infinity. X is the domain to infinity. The range, how low to high the graph is. The lowest part of the portion of the graph is down here. And the y value is negative 2. It is an actual point on the graph, so it is equal to. And either side, does not matter which one you pick, both sides of the graph are going to go up, up, up to infinity. On number 4, let's talk about, we haven't talked about zeros yet. Zeros, where is across the x-axis? Looks like across the x-axis. Let me erase these. Across the x-axis at 2 and 0. So 2, 0, and 0, 0. Zeros are the same thing as x-intercepts. So you have 2, 0, and 0, 0. The y-intercept is where it's across the y-axis. Happens as at 0, 0. So it has that x-intercept. Doesn't always happen that way. The domain on number 4. So how far far left will the left arrow go, and how far right will the right arrow go? Well, they'll keep on going negative infinity to infinity. The range, how low to how high the graph is. So the lowest values, this is going to go down forever, and so will this one. So the lowest values are negative infinity. That's the y values, and they are going to go, the highest part of the graph, either way, is this point here. That y value is at 1. There's an actual point there. A graph is made up of infinite amount of points. So there's an actual point there. It's a closed point. And point is equal to. Zeros, hopefully you're saying those are the x-intercepts. That looks like at 3 and 5. 3, 0, 5, 0. X-intercepts, same thing. 3, 0, 5, 0. Y-intercept, where is across the y-axis? In this case, across the y-axis at negative 3. So 0, negative 3. On to the back. Describe the restricted discontinuous domains and ranges. So for these, I would look at the asymptotes first. What is the equation of this asymptote? And it looks like it's at x equals negative 1. What is the equation of the other asymptote, the horizontal asymptote? Hopefully I'm saying horizontal, you're saying y equals. Y equals across the y-axis at negative 3. These asymptotes are going to help us name the domain and range. So the domain from left to right. So as this graph is as this graph is coming in from the left, it is coming in from negative infinity, the x values. Okay, here's at negative 8, negative 10, the x value is negative 12. It's coming from negative infinity. Where does this portion of the graph have its limit at? It ends, there's an asymptote at x equals negative 1. So that's where this portion of the graph has a limitation. It gets up to negative 1 and that's it. The next portion of the graph here starts at negative 1, just to the right of negative 1, and it'll continue right forever and ever to infinity. The right is the asymptote, or the, like, if it keeps going right, it's at 6, here's at 8, here's at 10, it'll continue on the x values forever and ever. The range, we start from the bottom to the top, so this graph is going to continue down forever. So we start from the bottom, we're starting down here, that's negative infinity. Y value, where does that portion of the graph top out at? It tops out at y equals negative 3. We need to look at the range of the other portion of the graph. The other portion, the lowest part of the graph, is over here on the left, and the y value for that is at negative 3. And where does that top out? It doesn't. It goes to infinity. Up to infinity. On to number 6. Number 6 for the domain. How far left will the graph go? Well, there's a filled-in circle here. That's the farthest left point. There's no arrows on here, so this is the farthest left. Is negative 7. So we say negative 7 is the start. Follow that line. It goes to right here. That point is at the x value of 1. Well, there's also, it ends here, but it begins, there's a hole at 1 also. So if you remember me saying about squishing the graph, so if you squish this graph horizontally, it would, this like this portion here would go and fill this in here. So then the domain keeps on continuing, filled in, open, but this part here would come down and fill that in if it's squished. We keep on following the domain all the way till 9. So 7, negative 7 is less than, it's a filled in circle, equal to x. keep following it. Keep following. It's like you're putting all of these together, all these pieces together, sliding them together, and be less than or equal to 9. Saying you can stop anywhere between -7 and -9. You can name any x value, and I'll find a part of the graph that's there. Is what this domain is saying. The range. The range is the lowest point, lowest coordinate to the highest coordinate. So we have the lowest point that I see on the graph is down here at 9, -2. The y value is at -2. That's where we're going to start. It is a filled in circle, so it's equal to. And as I go up, the highest part of the graph that I'm seeing is this up here at 5, 6. This is the highest part of the graph. The y value there is at 6. And it's an actual coordinate there, so it's equal to 6. So this is saying all of your graph, I can name any y value between -2 and 6. My graph, there's a graph in between those points. To D. This is where in class I had you draw a picture. On the test I will give you the graph of each function. So here are your asymptotes. This asymptote is at x equals 6. Graph is a rational function. So when you're doing this, you have to look at which of the following describes the end behavior of this function as x approaches negative infinity. So as x approaches negative infinity. That is the left side of the graph. So I'm looking here. What is happening in the graph? Where is the y values? Where is this going as I'm going further and further left? Well, you should be seeing that there's an asymptote right above it. This asymptote here prevents this graph from going any higher. So as x goes to negative infinity, the y value is actually going to go, it's going to top out at 0. So the y approaches 0. On number 8, I asked you in class to draw the pictures of each one. So they're upside down U-shaped, upside down U-shaped, cubic, another cubic looking graph, and a U. So we're looking for whose end behavior is the y value is approaching negative infinity, so that's one down, as the x is approaching positive infinity. So I'm looking, if I were to draw a graph of this, I'm looking for a y value that's going down as x approaches positive infinity. So I'm looking for the right side of the graph. This is the right side that is going down. So the right side of the graph that's going down. It's like this right side of the graph is going down, this right side of the graph is going down. The middle equation, the right side of the graph is going up, so now the fourth equation, the right side of the graph is going up, and the fifth equation, the right side of the graph is going up. So only two that the right side of the graph is going down is the first one and the second one. If you guys have any questions on this, please come in and ask me. I'm available every morning before school, starting at about 6:30 to 7:30. I'm every day after school. Just come to the math planning. Thank you.